Wanted to look at similar triangles and how they can be used to find things like the height of flagpoles or buildings or shadows or something of this nature. As we can see from this question, it says that um, a building with a height of 40 feet casts a shadow that's 25 feet long. And at the same time of day, a flagpole casts a shadow that is 15 feet, should say, long. How tall is the flagpole? So what we see here is that the flagpole itself and its shadow and the rays of the sun actually form similar triangles. And we can use these similar triangles to find out, this missing side length. And in order to do that, all we have to do is to set up ratios using comparative or corresponding sides. In this triangle, we would see that x is the height of the flagpole would correspond with 40 feet, which is the height of the building. And we would take the shadow of the flagpole, which is 15, over the shadow of the building. So once again, I have height of the flagpole, height of the building, right here, shadow of the flagpole, shadow of the building. And what we're really, of course, what we're doing is setting up proportions. This side will correspond to the side of the building, and the shadows would correspond with one another. Now, once I get it to this point, all we have to do is to cross multiply and solve for x. And we can go x, in order to solve this, we would say x times 25 equals 40 times 15. And then we would say 25 times x, which is 25x, not 2x, 25x equals 40 times 15, which is 600. And then I would divide both sides by 25 to find out that x is equal to 24. So we would say the height of the flagpole is 24 feet tall. And all we have to do is set up our corresponding triangles. Now let's look at another situation where we have a 5-foot tall boy that casts a shadow that's 3 feet long. At the same time of day, a tree casts a shadow that is 18 feet long. What's the height of the tree? Once again, we could set up a proportion by using similar side lengths. We would say the height of the tree, or we could use the height of the boy. The height of the boy, which is his height, would compare to the height of the tree, and then his shadow would compare to the tree shadow. So let's go ahead and set up a proportion. I would say 5 feet over x, because that's the height of the tree, equals 3 feet, which is the boy shadow, over 18 feet. And then we would just, once again, 3 times x equals 18 times 5, and then 3x equals 90. Divide both sides by 3 to get x equals 30. So this is a way to use similar triangles in order to find some measurements indirectly. And once again, I hope this clears up any questions. If you have any questions or comments, just please continue to check out my website. Students, be sure to ask in class. Thanks.